working?
I think so. Yeah, I'm looking at your screen now. Okay.
Okay, so for instance, this problem.
There's something very unique about that parabola. It does not cross the x-axis. That means it has no real zeros. Also means the discriminant is negative.
Okay.
Let me explain a little bit more. Here, I'm going to make myself the presenter again. So we're looking at my screen now. If I had something like this, oh, hold on a second. I've got to turn my writing tool on. Let's say I had a polynomial that was x squared minus 7x plus 10. Okay, if I factor that, I get x minus 5 times x minus 2, which gives me zeros of x equal 5 and x equal 2. Which means if I graph that, I've got to go through that point and that point. And I know it's a parabola that goes up. So I cross the x-axis twice because I have real zeros. Now, when they talk about the discriminant, you know what the discriminant is? What's the...
No.
All right, let's go back and talk about the quadratic formula. Do you know what that is?
I know of it. I just can't remember exactly.
Okay, you need to memorize it. It's one of the things you're going to have to memorize in math. Even when you take your ACTs or your SAT. There's the quadratic formula. They usually teach you a song to memorize it. I never was taught the song, but being a math tutor, I've memorized it. So the discriminant is that part right there. B squared minus 4AC is the discriminant. Now, do you know what A, B, and C are for the one that I wrote for that polynomial? What's A?
Is it x squared A?
A is the coefficient of the x squared term.
So it's just 1?
Correct. A is 1. What is B?
-7.
And what is C?
10.
So if I want to calculate B squared, that's 49 minus 4 times 1 times 10. That gives me 9. My discriminant is positive. If my discriminant is positive, I have two real solutions. And I cross the x-axis twice. If my discriminant is exactly 0, I have exactly one solution, and I touch the x-axis. If my discriminant is negative, then it looks like the picture you showed me. In other words, it looks like this. It doesn't touch the x-axis at all. You've got imaginary solutions only when it looks like that. So when you look at this parabola right here, you know that it doesn't have any real solutions. It's not crossing the x-axis. And the fact that it does not have real solutions means the discriminant has to be negative. So the answer to that question is negative, based strictly on that picture, without knowing the formula. In other words, without being able to calculate the discriminant. We know it's negative because it doesn't cross the x-axis.
Okay.
Make you the presenter again. Let's switch back to you because these problems you're showing are a little bit unique. Might be such that I need to be able to see them. Can you blow that up a little? Here, no, I can read. Okay, so what is the discriminant here? What's the value of the discriminant? First of all, what's the formula for it?
Negative, or it's negative b.
Plus or minus.
Okay, so negative b plus or minus a.
All right, here. It helps if I can write. So I'm going to make myself the presenter again, and we will deal with this quadratic, but you can read it to me as easily as I can see it.
Okay.
So what was it? It was, hold on. It was f of x equals 4x squared. What's the rest of it?
Plus 2x plus 6.
Okay. Let me help you memorizing the quadratic and the discriminant. First of all, if I asked you, where's the vertex of that? Do you know how to find it?
No.
Well, this is very useful. Vertex is minus b over 2a, and that's only the x-coordinate of the vertex. So in this case, what's the vertex?
Negative 2 over 8.
Which is negative 1/4. That is the x-coordinate of the vertex. Okay? So when you have a polynomial or a quadratic that's in standard form like this, this is the fastest way to find the vertex. Minus b over 2a. Okay? Now, if you look at the quadratic formula, what do we have? We have minus b plus or minus the square root of b squared minus 4ac, that's the discriminant, all over 2a. Well, notice what the first half of the quadratic is. It's the same as finding just the x-coordinate of the vertex. And then the rest of the quadratic, just remember there's a plus or minus the square root of the discriminant. So you want to memorize the minus b over 2a. You want to know what the discriminant is, b squared minus 4ac. Put them together and you got your quadratic formula.
Okay.
Okay. Now, their question on this problem was, what's the value of the discriminant? Tell me what it is.
So I put it into, which formula do I put it into?
That one right there. That's the discriminant. It has its own name because it's so useful. Whether that's positive, negative, or zero means a huge amount. So frequently when you have a quadratic, the very first step is figuring out what the discriminant is. Because you might have imaginary solutions. If you come up with a negative discriminant, it means you don't have any real solutions. You might be done with the problem. So you might not have to solve it. So it's very useful to know what that discriminant is. So the discriminant is b squared minus 4ac. So what is that here?
That is 2 squared minus 4 times 4 times 6.
Which is 4 minus 96.
Oh, yeah.
I think. Let's see. 4 times 6 is 24. 4 times 24 is 96, which is negative 92. So the fact that the discriminant is negative means what?
That there isn't...
that you have exactly 2 imaginary solutions only.
Yeah.
Remember, there's only 3 possibilities. It's negative, you have 2 imaginary. It's positive, you have 2 real. And if it's exactly 0, if this b squared minus 4ac is exactly 0, then you have exactly 1 real solution. And it's obviously going to be minus b over 2a. If this whole thing is 0, well, then all of this goes away. So you end up with minus b over 2a is your 1 real solution. So that's why they're talking about these discriminants, is because what's the next one? Without me making you the presenter, what's the next question say? Or actually, what's the second part of that question say? First part says, what's the value? We got it to be minus 92, if you want to fill that in.
Yeah, I'll fill that in, minus 92. And then the next one was, how many distinct real number zeros does F have?
0. Because the discriminant was negative.
Okay.
Any more on that question?
There's another one with the parabola that's below the x-axis, saying if the discriminant of x is the discriminant of x positive, 0, or negative.
Okay, here, let me draw. You tell me, it's below the x-axis. Does it open up or down?
Opens up.
So it's something like this?
Yes.
Okay. We cross the x-axis right there and right there. Those are real zeros.
Okay.
So what does that tell you the discriminant has to be?
Is it positive?
You have a positive discriminant, you have 2 real zeros. You have a negative discriminant, you don't have any. In other words, if I'm looking at a parabola that does something like that, or even this, neither one of these blue parabolas cross the x-axis, which means they do not have any real zero, which means they must have only imaginary zeros, and 2 of them. You have a quadratic, you have 2 solutions. Okay, what else? And let me know if you need me to make you the presenter, if it's something that's hard to describe.
Okay, it's the same. It's 3x squared plus 24x plus 48.
And what's the question?
The discriminant and how many real zeros.
Okay. We could do this the hard way, which is to figure out b squared minus 4ac. And the reason that's the hard way is because you have to pull out your calculator to figure out what that is. Do you have your calculator in front of
you? Yes.
Go ahead and do it the hard way. And I'm going to show you a slightly easier way to do this problem. I think it's easier. Yeah, got to be easier.
So do 20. I'm doing 24
squared
minus 4 times 3 times 48. It says negative 552.
That's negative 552 all by itself, or that's positive. What's 24 squared?
24 squared, so that's 24 times 24.
What is that equal to?
576.
How much?
576.
Okay, now what's 4 times 3 times 48?
4 times 3 times 3. 576.
576?
Yep.
Okay. So what's our discriminant equal to?
0.
Which means what? What's the next thing they ask you? That is the discriminant.
How many real zeros
So
does F have?
remember, we only have 3 choices. We can have a positive discriminant, a negative discriminant, or a discriminant equal exactly to 0. So what is, when it's equal to exactly 0, what does that mean about real?
There's 0.
Means you're looking at a parabola like that. What does that mean? It just touches the x-axis in one spot only.
There's only one real 0.
That's what it means. When your discriminant comes out to be 0, you have one real 0. Okay? Any other questions on this one?
What?
Do you have any other questions on this particular function?
I don't think so. I did have questions on word
Clear way to do this, so that we don't have to deal with these big numbers and you won't have to use a calculator. What can I factor out of every term? Is there a greatest common factor? Right? Multiply that back together again, you get what you started with. Correct?
Yep.
Now I can work with this only. That 3 is merely a vertical stretch factor. So it doesn't affect the number of zeros you have. It doesn't affect the anything. It affects the shape of the parabola. But the zeros of the parabola are going to be exactly the same. So now to do b squared minus 4ac, I do 8 squared minus 4 times 1 times 16. Well, that's 64. That's 64. 64 minus 64 is 0. So by factoring out the 3, I end up with much smaller a, b, and c, which allows me to figure out the discriminant without a calculator.
Okay.
So it usually pays, whenever you're dealing with quadratics, if you can factor out a greatest common factor, a number, it usually pays to do it. Because what you're left with is a much simpler quadratic.
Yeah.
And in fact, I can factor that really easily. It's x plus 4 times x plus 4. And now I can see that I have a real 0 at x equal minus 4, and I have it twice. But I only have one real 0. It does have a multiplicity of 2. I don't know if you know what multiplicity means at this point. Have they talked to you about multiplicity yet?
I think it's been brought up, but I don't really know.
Well, here's a perfect example. That's multiplicity of 2. Why? Because I've got 0 equal to x plus 4 times x plus 4. Well, my solution is x equal minus 4, but I get it twice, right?
Yeah.
That's multiplicity of 2. And you write it kind of like that. Most problems before when I did it, and I ended up with x minus 5 times x minus 2. Remember that gave me two solutions, x equal 5, x equal 2. Each of those has a multiplicity of 1. The multiplicity is important when you start trying to figure out whether a graph crosses the x-axis or touches it.
All right.
In other words, if I have a graph that does that, it's just touching the x-axis. So whatever that solution is, it's going to have a multiplicity of 2. If I have a graph that does this, I've got 1, 2, 3 zeros. They all cross the x-axis. That means each one of them has an odd multiplicity, either 1, 3, 5, or 7. When you see a function do this, this 0 is odd multiplicity. This 0 is even multiplicity because it didn't cross the axis. It touched it.
Okay.
All right. I don't want to get into that too heavily if we haven't covered it particularly. What else you got? You got something you can describe, or do I need to make you the presenter?
I can describe it.
Okay.
It's a multiplying complex numbers with the two parentheses multiplying.
Okay.
So it's in the first parentheses is 5 plus 2i. And then the next parentheses is negative 5 negative I.
You want to use FOIL on this. You know what FOIL is, right?
Yes.
Okay, that's all you do. FOIL is the same as every term by every term. In other words, I'm going to multiply that by that. Then I'm going to multiply that by that minus I. And then I'm going to multiply the 2i times the minus 5. And then I'm going to multiply the 2i times the minus I. Then I'm going to add them all together. So what do you get when you do each of those 4 multiplications?
Negative 25.
What's next?
I.
What's next?
Negative 5i.
No, you do this, and then you do this. Oh, excuse me. What was I thinking? You're absolutely correct. Okay, and then what's the inside?
Negative 10i.
And what's the last?
Negative 2i.
Negative 2i squared. When you multiply I times I, you get I squared.
Correct.
Okay. Now, this is key because that is a real number. It's not an imaginary number anymore. I squared is negative 1. Okay. So now I'm going to combine like terms. That becomes minus 15i. And that becomes plus 2 because I squared is negative 1. So now combining everything gives me minus 23 minus 15i written in proper format, which is a plus bi. Usually every complex answer you give, you want it to be in this format. You want the real part first, and you want the coefficient of the imaginary part along with the I. But
so negative 23 minus 15i is the correct answer.
Yeah. The only key on any of these is this I squared. Everything in I squared, always convert it to negative 1. Now, adding complex numbers is extremely easy. You add the reals, you add the complex. Subtracting complex numbers is very easy. Add the reals, or subtract the reals, subtract the complex. The only thing that is a little hard is dividing. You have a division complex number. I can make one up if you don't.
I do want to go over. There's 3 more, I think, of these complex problems.
Okay, let's go over one by one. We got time.
So first parentheses, -1, -3i times -1 plus I.
Okay, you do it this time.
Okay. So first term is 1 minus 1i, or just minus I. Three plus 3i. Well, minus 3i squared.
Okay, now simplify that. Do it in two steps rather than all one step. Combine those. Those are both i's. You can combine them.
Okay, 2 plus 2i.
And convert this to a number.
Isn't it just 3?
It's plus 3.
Plus 3.
Because I squared is minus 1. So you're doing a minus 3 times a minus 1. And then finally simplify that by combining the two numbers.
4 plus 2i.
That's your answer.
Okay. So I have 2 more of those. Just want to make sure
That's fine. Oh, go ahead.
So 3 minus 3i. And then minus 2 plus 2i.
Okay. Subtract the reals. What do you get?
So subtraction changes the sign in the right side, right?
Yeah, this negative sign right there needs to be applied to everything in the parentheses.
Okay.
So do the reals first.
Does that mean multiply it on, so it'll be -2 plus -2i?
What's that? What's the reals? 3 minus 2. What is that?
3 minus 2? Why are we doing 3 minus 2?
Because there's the real, and there's the real. And you're subtracting the reals.
Okay. 3 minus 2 is 1.
Okay. Now you got minus 3i minus a plus 2i. Or you could write that minus 3i plus a minus 2i, which is the easiest way to write it so that you don't make a mistake. What's that?
That's a -6i.
We're adding, not multiplying.
Oh, yeah.
Okay? So that's how you do it. In other words, whether you're doing addition or subtraction, it's exactly the same. You subtract the reals, you subtract the imaginaries. Or you add the reals and you add the imaginaries, depending on whether you're doing subtraction here or addition.
Okay, so,
Ready for another one?
yep.
Okay, go ahead.
That was 1 minus 5i, correct?
Yeah, I think so, yeah.
I think it's saying it's wrong. I'm not sure why.
What was the problem again?
3 minus 3i times minus 2.
Is it times or minus? Makes a big difference.
Oh, times. Oh.
In other words, I don't have a minus sign in there. What's the rest of it?
-2 plus 2i.
Ah, okay. I put your negative sign out in front of the parentheses. That was what the problem was. Okay, so this is multiplication. Just do it just like you would FOIL anything. What do you get?
So -6 plus 6i 6i plus 6i minus 6i
Squared. Don't forget, when you're multiplying I times I, it's squared. If you multiply x times x, it's x squared.
And that will change to +6.
Correct. So now we have a -6. I'm going to combine those two to get plus 12i. And that whole thing becomes +6. So that cancels with that, and the final answer is just 12i.
Okay.
Go ahead and put that in. Right.
I'm going to see if I can do this one on my own.
Which one? Is it another one?
It's another one. 4 minus 2i
Hold on.
times 4 minus 2i times -5 plus 4i.
You've actually done the last two on your own. Go ahead.
So -20 plus 16i plus 10i plus -8i or minus 8i.
Okay, what goes after the 10i?
Squared. Minus 8i squared.
Okay. Now, simplify that.
-20 plus 26i plus 8.
For a final answer of?
-12 plus 26i.
There you go.
Okay. Now we're looking at complex solutions.
Okay, they didn't give you any division. Or addition or subtraction. I'm surprised. Okay. So the only thing they've given you so far is multiplying.
Yeah.
All right.
So I got this equation.
Okay.
3x squared minus 5x plus 1 equals 0. And we're supposed to find the solutions of the quadratic equation. And some of the solutions look like a negative fraction, or a fraction plus minus another fraction, but the numerator is
I don't need multiple choice to solve this. It's not even helpful. How am I going to solve this? What do I use to solve this?
I'm not sure.
Quadratic formula. Quadratic formula solves all quadratics. If I can factor it, it's easier to factor it. But if I can't factor it, then it's the quadratic formula. So immediately, especially if you suspect that your solutions are going to be complex, and the title suggests that, so you always get your complex solutions from the quadratic formula. So tell me what the quadratic formula is again. Let's get you to memorize this.
Oh boy. A squared plus...
No. What's the first half of it? It's also the formula for finding the vertex of a quadratic.
isn't it b squared?
Minus b over 2a. That's another one you want to memorize. In other words,
Okay.
if they gave you this problem and they said, where's the x coordinate of the vertex, that'd be the fastest way to get it. Would be to put it into minus b over 2a. So memorize that. And then once you've memorized that, the quadratic kind of comes fairly natural if you know what the discriminant is. There's a plus or minus, you know that. There's a radical sign, you know that. What goes under the radical? This is called the discriminant. Well, no, let's list the letters first. Let's put the formula first, and then we'll fill it in.
A is 3.
Hold on. It's b squared minus 4ac. That is the discriminant. B squared minus 4ac. It is not the square root of that. The discriminant is b squared minus 4ac. What's it all over?
2a.
Right, because we got to have this minus b over 2a. So there's your quadratic formula. This is what's going to allow us to solve for the solutions. And I don't know by looking at it whether the solutions are real or complex, but we'll certainly find out. If that discriminant is negative, then we're going to be taking the square root of a negative number and we're going to have imaginary solutions. So that's why the discriminant is really important. But in this case, they want all solutions, so let's just go ahead and substitute everything. What do you get? Minus b.
Minus plus 5, or so 5 plus minus negative 5 squared.
Hold on, don't forget the radical sign.
4.
Don't forget the radical sign. What's A?
3 times 1.
Okay. So what is the discriminant? Is it positive or negative?
It's negative.
No. Minus 5 squared is 25.
Oh, okay.
25 minus 12 is 13. So it's the square root of 13. And 6 goes down there. Okay. So if I simplify this, I get 5 plus or minus the square root of 13 all over 6. Now, that's a real solution. It's 2 of them. What that plus minus means is that one solution is 5 plus root 13 over 6. The other solution is 5 minus root 13 over 6. That's what the plus minus means. Okay? Now, I should say one last thing before we leave this problem. That is not in A plus BI format. In other words, when you use the quadratic formula to solve it, you don't end up with it in A plus BI format. So how can I change that? Well, it's not. Let's wait till we get a imaginary one before I talk about that. I'm sorry. Go ahead and give me your next one.
So the answer is, because the answers I'm looking at are negative 5 over 6 plus minus the square root of 13 over 6.
That's wrong because it's positive 5.
Okay.
So it's 5, 6.
5 over 6 plus minus the square root of 13 over 6.
That's it. That's what we got when we solved it.
All right, the next equation is 3x squared minus 2x plus 7 equals 0.
Okay. This one's going to give you a negative discriminant. I can tell already because C is really big. So, give me the quadratic again.
The quadratic formula.
Uh-huh.
So B
No.
squared.
Give me the quadratic formula with just letters, no numbers substituted yet. Remember, the discriminant is way over there. So there's a lot of stuff that goes before that discriminant. What's the first part? What goes there and what goes down there?
A.
No, it's minus B over 2A. That's the formula also for the vertex. Now, what goes inside? What's the formula inside? The radical sign.
Minus B squared.
Not minus B squared.
Just B squared plus minus 4A
C.
Time C. Yeah.
Okay. You need to memorize that because they're not going to give it to you. They don't give it to you on the SAT test or the ACT test or any test. Unless your teacher is sparing you by not making you memorize it, that's something you need to memorize to go forth in math. However you need to do it, you need to memorize it. I wish I knew the song they teach. I don't think I would know my ABCs if they hadn't taught it to me in a song. In fact, if you ask me which comes first, I or J, I probably have to sing it. A, B, C, D, E, F, G, H, I, J. Oh, I comes before J. Okay. Same thing with things like this quadratic formula. If you can figure out a little technique to memorize it, that's the way to go. Okay. So now let's fill it in. What's minus B?
2.
Keep going.
Plus minus the square root of negative 2 squared.
Notice that B squared is always positive. So if you want to short step this a little bit, you can just square 2 and write 4 in there. And it doesn't matter whether B is negative 2 or positive 2. B squared is 4. So,
minus 4 times
math in my head, but the rest of it you want to be very careful with. You want to do the rest of it exactly like this. You don't want to ever do this in your head. What's A?
3.
C?
7.
Now, the way to go from here is to always do that next. Those 3 numbers, not including the negative sign. So what's 4 times 3 times 7?
84?
Correct. So it's 4 minus 84, right? Which is minus 80. All over what? What's 2A?
3 or 6.
Okay. Now, there's a lot we need to do to this to simplify it. So I need to make some space. I'm going to keep erasing this because I want you to memorize it. By the time we're done today, you'll have that thing memorized. I guarantee it. Okay. Let's start with the square root of 80, of negative 80. We gotta do something with that first. Now, when you have a square root of a negative number, the best way to look at it is to always take the square root of negative 1 out and then the square root of a positive number like that. Doesn't matter what it is. If I had the square root of negative 7, it'd be the square root of negative 1 times the square root of 7. With me?
Yeah.
The reason we do that is because that's I. So what we really have is the square root of 80 times I.
Yeah.
Well, that's still not final, because square root of 80 is not simplified. If you can find a factor that is a perfect square number, then that's not simplified. What factors of 80 are perfect square numbers? Not both of them. You just need one perfect square number.
5?
5's not a perfect square number. What are your perfect square numbers? 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. This is what I mean by perfect square numbers. And when you're trying to simplify a radical, these are your key numbers. You've got to find a factor of 80 that is one of these numbers. Otherwise, it's not simplifiable. Well, are any of those factors, and it doesn't have to be the largest one, but it'll save you 2 steps if you happen to find the largest one. Is 49 a factor of 80?
No.
36?
No.
25?
No.
16?
No.
Yes. 16 goes into 80 exactly 5 times. So I turn that 80 into 16 times 5. And then the square root of 16 is a whole number. So that becomes 4 root 5. So square root of 80 is not simplified, but it simplifies all the way down to 4 root 5. Okay? You with me?
Okay.
So now here's what I got. I got 2 plus or minus 4 root 5 I, because I still got that square root of negative 1 in there, all over x. Now I'm still not done. How can I simplify that?
I'm not sure.
Well, you're looking at even numbers in the top and bottom. Whenever you see nothing but even numbers, you can always divide top and bottom by 2. So if I divide the top and bottom by 2, now I get this. There's an answer. You see how that I got to that from the lower right?
Yes.
Okay. However, here's the situation where this is not in A plus BI format. So that's not usually the way you present the answer. What you're going to do is divide it into 2 fractions. You got that part of it, and then you got this part of it. And what that gives you is 1/3 plus or minus 2/3 root 5 I. And notice that that is in perfect A plus BI format. A is 1/3, B is 2/3 root 5, and then I've got my I. Now, was this a multiple choice?
Yeah, I already entered it and it was correct.
But which one was it? Was it the format on the left or was it the format on the right?
Left.
Okay. So they didn't force you to take it all the way down. Perfect format is considered A plus BI. Whereas that's not really in A plus BI format. But that's fine. They don't care at this point. Okay? What else you got?
Negative 9x squared plus x plus 3 equals 0.
Okay. It's quadratic again?
Yes.
What is it again? This, incidentally, is how you should begin virtually every math problem.
I think I remember.
Starting out with the general formula.
It's negative b plus or minus the square root of b squared minus 4ac over 2a.
Very good. I told you you'd have it memorized. Okay, now plug it in.
So minus 1 plus or minus this 1 minus 4 times negative 9 times 3.
Yeah, now you don't have to do the discriminant the way I suggested. I just find it's the easiest way. In other words, I leave it as a subtraction problem, and I just take these last three numbers and multiply them. All over, what's the bottom, the denominator?
2a.
What's that number?
Oh, it's negative 18.
Okay. So now we have what? What's in the radicals?
$96.
Multiply 4 times 9 times 3.
Wait, 4 times 9 is 28,
No,
right?
No, it's 36.
36, correct. Okay. So
36 times 3 is 108.
okay.
So what's inside the radical?
1 minus 108.
No. You got two negative signs there. In other words, if you do it the way I suggested, where you always multiply those three together first, then what you've got is the square root of 1 minus a minus 108. Do you not?
Yes.
Which is 1 plus 108, which is 109. In other words, this has real solution, not imaginary, because the discriminant was a positive number. But notice how easy it was to make your mistake that you made. In other words, when you go to finding out what that number equals, a lot of people make mistakes when they have a lot of negative signs. They just do. You put another negative sign in there, half the people are going to miss it. So take those three numbers, multiply them together, whatever you come up with, subtract it from b squared. That's the way to do it. Now, is 109 simplifiable? What does it need to be simplifiable?
A perfect square number within it.
As a factor of it. So I'm going to write the perfect square numbers again. 1, 4, 9, 16, 25, 36, 49. I don't have to go any higher than 49 because I know 64 is not a factor of 109. So are any of those perfect square numbers factors of 109?
I don't think so.
You're right. They're not. None of them. Which makes that the answer. If you cannot find a perfect square number that is a factor, then it's simplified. Let's just talk about that for a second. If I say the square root of 10, is that simplified?
No.
What should it be? Is there a perfect,
2 times the square root of 5.
is there a factor of 10 that is a perfect square number?
1.
That doesn't count. I shouldn't have written it. Is there a factor of 10 that is one of the perfect square numbers on my list now?
No.
That makes it simplified. That's simple. Now if I ask you, how about square root of 8? That's simplified.
4.
Give me the whole answer.
2 times the square root of 4?
No. First of all, split it up into its factors, putting the perfect square number first, right? 8 is 4 times 2. But the square root of 4 is 2. That's why I need a perfect square. Because to simplify these, you don't simplify square root of 10 into square root of 5 times square root of 2. That's not simplified. That's 2 terms now instead of 1. So we don't do it. So it's not just a question of whether you can factor 10. It's a question of, can you find a factor that is a perfect square number? And you cannot for 10, but you can for 8. You cannot for 6.
So the correct answer would be negative 1 over 8 and then 18 over 18.
No.
Oh, wait, 1 over 9.
Hold on.
Plus or minus.
Hold on. First of all, that's the answer right there. I can't simplify it. I can't divide top and bottom by anything. So is that one of your multiple choices?
No. Well, yes. There. It's divided into, all of them are divided into 2 fractions.
Aha. In other words, they have split it up in this case. They want you, in this problem, they want it in A plus BI format. Well, what's minus 1 over minus 18? 1/18. That's the real part of the answer. In other words, here's what we're looking for, is A plus BI format. Okay? Well, the A is 1/18. The B, and this is not an imaginary number again. So they didn't make this an imaginary number, they just split it up. That works also. And in fact, I don't need that negative sign on the 18. Because if I make that positive, all it does is turns that into a minus plus instead of a plus minus. That's the same answer. So this should be one of your multiple choices.
I have minus 1/18 plus or minus the square root of 109 over 18. 1/18 plus or minus the square root of 109 over 18i. And then 1/9 plus the square root of 109 over 9.
Okay, there's no I. You're not going to have an I because we don't have the square root of a negative number. It's the only time you ever produce an I. Okay, we're taking the square root of a positive number. So that solution is not correct. However, there's a number of ways this can be written. You can write it like I just did. The big circled answer, that's one answer. Okay. I can also switch this and make it, no, I don't think I can make it minus 1/18. The answer's got to be this, but I could do plus or minus a negative square root of 109 over 18. I could do that. Don't see the advantage of that. Because this is the same thing as saying 1 over 18 minus or plus, take away that other negative sign. This is actually the answer I prefer the most, where A is real and B is real. It's 1/18 minus or plus square root of 109 over 18.
Okay.
That do it for you today, Nathan?
Yep.
Good. Remember that quadratic formula.
Okay, I will.
I'll talk to you next time, Nate.
All right. Bye-bye.